The RF layout functionality is designed to specifically understand the RF domain elements, to provide the user with a powerful and comprehensive toolset for integrated RF design. Utilize an equivalent RF library created from third-party RF point tools. Schematic integration and layout verification is achieved through tight integration with those leading RF point tools. RF design elements are understood as native design objects, with support for many RF operations including parametric-driven RF elements and intelligent RF circuit placement. So let's take a quick look at the RF layout's parametric shapes and placement capabilities. During design creation, you can place the RF models using XDX databook, similar to how you place any other schematic symbol. The RF models have their parametric parameters included in the library, and are available to be placed as soon as they are added to your library. Finding the correct symbols is very straightforward, since the name of the symbol matches the name in the third-party RF tool. You can either browse or search for the symbol using XDX databook. After placement, the RF symbol's parameters can be modified in the schematic, or in the layout, which I will also show later in this demonstration. Native support for all common variables and most expressions from the third-party tools, and also mathematical operators in the variable names, makes it possible to use complex expressions to meet your design needs. The variables are used to drive the physical size of the RF elements. As in this example, where the length parameter on the microstrip line is driven by a variable. To aid in the placement and movement of RF circuitry during PCB layout, it's possible to create groups in the schematic, where subgroups can be used to split the circuitry into more manageable pieces. In this demonstration, I will divide the LNA by its input, output, and amplifier stages. With the grouping set up, now let's take a look at the placement process and PCB layout. To efficiently lay out the RF circuit, several ways are supported to place the RF elements. One way is to use the planning group concept, which is supported in the RF design process. It will let you plan for the RF circuitry early in the design process, before the circuitry is fully optimized or even complete. RF layout provides full auto arrangement of a planning bubble, but can also be limited to subgroups and individually selected elements. With the circuitry carefully grouped, it is now easy to identify and move the different pieces of the circuitry independently. Moving and connecting shapes is fast and easy, as the cursor will always attach to the pin. Simply drag it close to other shapes and release it, and it will snap into place. A subset can be moved and connected with other shapes as a unit, and by stepping through the non-connected pins, you will have full control over which end to connect. To automatically arrange a subset of the circuitry, simply select the shapes you want to arrange, and define a seed on the fly for them. Changing parameters on the RF shapes within PCB layout is easy. Simply double-click on any RF shape, and the RF parameters dialog displays the editable parameters of the selected shape. Edit the parameters, using absolute values or type expressions directly into the form. Parameters can be modified on multiple shapes in one operation, and the dialog will only display parameters that are common between the selected shapes. If you are defining the physical size with variables, the equation editor will help you find the available variables for the selected elements. Variables can also be modified or added using the Variables and Equations dialog, invoked from within the Component Explorer. Variables added in layout are back annotated to the schematic, ensuring that the schematic and layout are always in sync. Type in new values directly into the form, or create complex expressions using the equation editor, which will list all of the available variables for the currently selected group. Toggle between the expression and the actual value to ensure that the equation can be resolved. Then modifying a variable will instantly update all RF shapes using this variable. This will allow you to control the physical size of entire circuits, making it easier to manage a complex RF circuitry. If We've now seen how by providing native functionality for RF design operations and strong integration with leading RF point tools allows you to integrate complex RF circuits and validate their functionality after they've been implemented in the system design. You can then also safely make adjustments to the RF circuitry with reduced lead time and increased productivity.